let's get started. So let's welcome our speaker, Pushpi Paranamana from St. Mary's College to share with us bridging theory and applications, implementing modeling activities and project assignments in differential equations 2 course. Thank you.
Yeah, thank you for the introduction and thank you for having me here. So I am going to, so I will share a little bit about my experience and, more like progression or the development of using these activities and projects in my differential equations 2 class. Oops. Okay. To give a little bit of background, because I'm sure people have questions about why it is differential equations too. So in our at St. Mary's, there's a linear algebra and introduction to differential equations class, which is more linear algebra and then some first order, second order differential equations. And then there is a differential equations 2, which is higher order equations. And then we look at linear systems, how to find solutions, nonlinear systems, phased plane analysis, Laplace transform, Fourier series. And if we get time, so if I get time, I usually introduce heat equation, and I don't have time to wave or anything else. So this is the class I teach, and I'm going to talk a little bit about how I implement modeling activities and also projects in this class. I will be talking more about my experiences, rationales, how things went, and what are the activities I did, rather than talking about particular, topics of projects. So my class is mostly math majors, and we have a dual degree program. So STEM students can do a engineering degree with University of Notre Dame. So I have a lot of engineering students as well, and some chemistry and physics students. So this is how I started doing things. The first time I was teaching, it was a pretty standard lecture-based class with homework and 3 midterm exams. And then at St. Mary's, there's a writing requirement. All the math majors should do a writing project in each high-level class. So there's a writing assignment and then the final exam. So it was pretty standard. I taught it, but I felt like it was dry, and I love differential equations, and I felt like there should be more to it. And the students learned a bunch of techniques and they use it, solve problems. But I mean, they did it well, but they didn't see the, big picture, like where these things come from, or basically the beauty or the potential of differential equations. So I was thinking I need to change this the next time I'm teaching. So because always differential equation has more live in it and not just formulas and dry calculations. So that's basically why of what I was doing, and how I did things it's more work in progress. So today I will talk about 2 things I implemented. The last time I taught, which was last semester, I did first day modeling activities. So I used these similar resources and modeling activities in the first day of class to motivate the students and make things exciting and engaging. So also, instead of final exams, I decided to, final exams are fine. We just test the techniques. The students to the techniques, and if they get the right answer, there's that or partial credits. But my goal was more like to make them see the big like applications or how these problems are used or the techniques are used in research, and make them think about how to explain the solutions, qualitative analysis, things like that. And then they had to do a write-up. So to talk about first day modeling activities, I will start from the beginning, like the second, after teaching the first time, as I told you, I was thinking about how to use more active learning strategies. So I was searching online, and then I came across with this M&M activity. I'm sure all of you know that. If not, M&M is, so it's to model change in population. We toss the M&Ms. If the candy lands with an M upside, we assume it's like a dead person, and remove those candies and count the remaining candies. So at each step, that's the number of people or the population at that particular time, and we repeat this for multiple iterations. So we have a table of, the iteration number and the population at the current time, and the worksheet guide you to model the change in the population, and then arrive at a differential equation to model the population. So that's what I did first time, and the students had so much fun because they are not used to so much like activities in math classes, at least in our school. So it was fun, and then I thought about it, and the second time and after that I made slight changes where instead of using M&Ms, I used this type of seed, and there's a type of seashells. So I used them also in the worksheet and asked them questions like, what are the changes, or what different assumptions you have to make if we are using these different things. So I mean, students basically understood the point. If we use M&Ms, it's like 50% death rate, and if we use other things, it might be a different like percentage. And so it was interesting to see how students thought about things differently, more than just solving the problems. And they thought it was fun to see the where the equations come from. And I mean, when I'm teaching, I sometimes explain where the equations come from. For example, pendulum or predator-prey models. But this is like hands-on activity sometimes, and also they get a small flavor for research. So how did it go? The students found it very exciting and engaging, and also they thought it makes sense. Like these are not just formulas or dry calculations, and they were motivated to learn the techniques actually. And also during the semester, I didn't do much modeling because I had to cover a lot of content. But I always, when I introduce a model or an equation, I talk a little bit about, refer to these activities and talk a little bit about the assumptions or limitations, what are the extensions and things like that. So that's about the first day activities, modeling activities. And then I'm going to talk about projects, so how I used projects. As I mentioned before, I mean, I wanted to replace the final exams with some kind of project. So I used these simulated resources to do that. They were group projects, so groups of 3 students. And the assessment was, I gave them the last week of class to work on the project because I didn't want to like
burn them or have time constraints. So I gave like 2 class periods, I think, to work on the project, get together and work on the project. And they had to do a 20-minute group presentation and a group like article, 3 to 5 pages article at the end of the semester. And also I gave a form to fill out, like evaluate the peers so that they have some kind of accountability. I wanted to avoid like one person doing everything and others or someone not doing things. So there was a peer evaluation part. And so to talk about preparation, the topics I used last semester was humans versus zombies. This is a SIR type model. The resources I actually have linked it. You can go, if you go to Semioid resources, you can find these worksheets. And I actually used all those worksheets, but adapted in a way it fits to my class. I added some problems, removed some problems. Humans versus zombies is SIR type modeling, and they analyze the nonlinear system, linearize it, and then analyze it. They have to interpret the findings qualitatively. And then another group did algae population, and another group did the van der Pol oscillator. So preparation to this, so I actually sat down and went through all the resources. Then I picked the topics that I felt like had the difficulty level I wanted. I didn't want it to be too easy because it's the final exam equivalent, but not too hard either. And then after picking the problems I thought interesting and that the students can use the techniques they used in class, I changed the worksheets and adapted to my needs. So how did it go? I do have time. So I want to talk. I mean, overall, I think it was a positive experience, and that obviously there's room for improvement, but the students enjoyed it, and I think it was a good activity or experience for the students to think outside a little bit. And to see the applications or research aspect of the differential equations. So I want to talk about particular story examples. One group who did van der Pol oscillator, they were a bunch of engineering students. So they actually really enjoyed that this problem has like applications. They found how to use this to model the cardiac pulses. So they did research on, or they read on those things, and then they were so excited to present those things to the class. And the group who did humans versus zombies, they were brilliant. They were like, that was like 100% project. I would say they did coding using MATLAB and did all the plots, and then they even came up with a game considering the like population, which was their college. And it was they had really interesting results. And one particular story I want to share. So there was a chemistry student. She was so excited and motivated with all this modeling aspect and the research part of this. She signed up for the COMAP competition this year, which I thought was interesting. Usually either math majors or maybe engineering students will sign up, but she was a chemistry student. She was very motivated with this. And some lessons learned. So it's not about really differential equations, but these are new experiences for my students, at least in our college. So they, even though they do well, they don't know that they are doing well. So I have to, you know, tell them that this is not going to be like a textbook problem where you have the correct answer. It's not going to be straightforward. You have to explore things. It might take time. You might get frustrated, but I saw how they were achieving the results, but they didn't know that they were kind of lost and they didn't know that they were doing great. So I think I should be explaining those things, the different flavor of research or projects, which is different from exams, and also maybe explain the rubric, be transparent about how I grade things so that they are at ease in a way, and groups, assigning groups. So there are different students with different group dynamics. So you might have to be, you know, you might have to be cognizant about how you assign groups. And so reflections. So I do believe that these things enhanced student understanding. Definitely the activities increased engagement. I threw in some activities during the semester as well, but not modeling activities. So increased engagement, and also definitely it's improved their critical thinking skills. They had to solve, and then they had to interpret, they had to present also. Also they saw the big picture of, you know, differential equations, beauty and like the applicability of differential equations. And then they thought it was fun. I thought it was fun. And also for me, it's less grading, more like I thought it was meaningful grading rather than just grading bunch of exams. And I definitely think the students got a lot out of the experience. I will share some student comments. So a lot of them thought it was really fun to see the real world examples of what they learned, and how to relate those techniques into, you know, have the big picture. Especially into engineering. Some people thought it was fun to see the engineering aspect of it. Some people thought it's fun to see the like research aspect of it, like when they learned SIR model, not through the class, but through the projects, they thought, okay, this is what people do in research. And I thought that exposure was interesting. And the last two points were interesting because one student thought, oh my God, we were left alone. We had to figure it out, and it's the worst thing. But the others were like, we were left alone. We had to figure things out. It was great. It was not just me asking you to solve the problem this way. So I thought it was interesting to, you know, see the different perspectives. And yeah, for next time for sure, I will do these activities, but I want to also add some more activities during the semester, as in like at least one activity per chapter, so that they are kind of used to this type of thinking before the final project. I think that would be useful. And also without giving midterm exams, I am going to try to implement mini projects during the semester, so they, instead of final exam, they will do 2 mini projects and there's a final. So they will build a kind of a portfolio. Be transparent, as in what I mentioned before, like the students don't know they are doing great. They are a good student, they know what to do, and but they are kind of lost because they haven't done this before and they don't know if their answer is the right answer. So, and also I kind of plugged in my research as well and motivated the students to, you know, do more undergraduate research, which was a plus of doing these activities. Yeah, overall that was a positive experience, and I will definitely do these things in the future. Thank you.
Thank you very much. This is really good talk. So I wonder if there's any questions from our audiences here. Anyone? Yeah, Kara, go ahead.
Thank you very much. That was really interesting. Really good to see you having a go at trying these things. What intrigues me is I came across the M&M activity as a secondary school teacher, and I'm just been writing the first week of our first time we introduced students to both modelling and differential equations together in a stage 2 course. And I had it down as my first activity for that lecture, and then my colleagues are quite traditional in their thinking, and I remember taking it out again. But again, it's about third or fourth time I've heard about it being used, because I think it's such a nice, as you say, a practical way just to get students actually doing something and starting to realize that you can actually participate in these things. It's not all abstract. Yeah, no, it's good. But my actual question that I want to know is, we're thinking about now about doing using a final project instead of, well, we have to, our paper script is being set up such that we have no exams or tests. It's all sort of project based. And I'm just wondering what type of percentage, what type of assessment weighting did you put on your final project?
What type of projects I used?
Your final project that you get the students to do is, instead of the exam, what percentage weighting does that have?
Percentage, that's a great question. I think I have to stop sharing and find it because I don't remember. I think it was like 30%.
Oh, okay. Oh, that's good, because we have ours down to 30%, but we were wondering if that
20%. I don't know. There's a presentation part of it, and they had to write it up. So it was 20%, 15%, or something like similar.
Okay, so without the 30%, it's broken down into their actual what they've done, and then a component for the presentation, component for presentation skills. If you can share it with me, I will be internally grateful and give me something to think about and see.
So what's after this is a break. So even though we're getting close to the end of the time, I guess we can stay and answer a couple more questions if our speaker is available. But for the rest, if you have other plans, feel free to leave. Thank you very much.
Thank you very much. I enjoyed your talk. Thanks.
Yeah, bye.
Thank you so much. How do we say your name properly? Is it Pushpi?
Pushpi.
It is Pushpi. Okay, nice to meet you, Pushpi. I've emailed you, and I'm just replying to my own email to you, just asking about the group evaluation.
Definitely.
Thank you.
Yeah,
bye.